If you're still standing outside, ladies and gentlemen, please take your seats. We'll begin right away. Thank you. Session, room number 1, begins now. It's titled World-Class Solar Power in 30 Minutes, which will be delivered by Samir Maggon, founder and Search Ninja, SearchStax Inc. Ladies and gentlemen, put your hands together. Samir on stage.
Thank you. Mic check. Can you guys hear me? All right, great. All right, so hi guys. Yeah, you have to spend the next 30 to 40 minutes listening to me. I won't feel bad if you guys have to walk out, just in case. All right, so just to kind of give you guys an idea what what this 30 to 40 minutes you're going to get out of it. I think instead of kind of pointing out the agenda items in specific, I thought what I'll do is I'll create a list of things that what I want kind of the audience to get out of this session. So, what I'm really looking for, at least part of this session, is what you want to get out of is, get a familiarity around kind of Apache Solr. If you guys are already not aware of, most of you guys, or probably all of you guys, are Sitecore developers, and with the recent kind of Solr and Sitecore integrations and stuff like that. So most of you are familiar with it, but just in case, we'll just briefly touch on that. I'll touch a little bit about Azure Search and Solr, kind of high-level experiences that I've had and we've had as a company on those. Quick overview, we'll go a little bit deeper into Solr, give you a comparison of Solr topologies, how different ways of, kind of configuring Solr, what's used today in the industry, what are the best practices around Solr. Then we'll kind of go into architecting a production-grade Solr, along with Zookeeper. We'll go with a simple non-production kind of a deployment, and then go up to, cross-region, multi-region kind of a deployment, and how you kind of do that in a cloud environment or in your own data centers, right? Depends upon what the need is. We'll do backups, recoveries. We'll touch on that. We'll make it a little bit more complex. Add the cross-region replications around Solr, how to handle that, and then. At the end, what I have is I have a small demo, and I said it's a shameless plug around kind of, about our company and how we make it kind of easy for Sitecore customers to do it. Part of the reason I got to earn my trip to India from Los Angeles, so that's part of that. And then we'll do a QA session, and hopefully we'll have some interesting discussions. All right, great. Little bit about me. I went to school at USC, Los Angeles, 2005 batch, so it's been about 12 or so, 13, 14 years. I went to school. Entire career, my career has been spent in building kind of platforms and teams in the area of search. I've done enterprise search software companies. I've done consumer-based companies, working with YP.com, AT&T, and so on and so forth. And then I've spent 15 years, I believe my career started actually in Delhi at a document management company, Newgen. And that's where I got exposure to search. And I've been doing search since the last 15 years. And that's all I've done and made a career out of it. Currently, so today, I work at SearchStax. I founded the company about 6 years back. We are right now a team of about 30 to 40 people across the globe. We have customers in kind of 3 geographical regions, about 150 customers running Solr. With us, a lot of Sitecore customers today. And then, if you guys want to connect with me, I have my Twitter handle and my email address. So, that's me. So the first thing is, again, Sitecore and Azure Search. Right? I mean, all of you guys know, if you're running Sitecore PaaS environment, Sitecore kind of by default started, I think, a couple, last year or when they started, kind of by default came with Azure Search, right? That was the default search engine. Whenever you did a Sitecore deployment, Azure Search was kind of part of it. I believe still is, and that's kind of what you do, right? And in the on-premise environments, you still had a choice of you've seen that's bundled in, or you had other options. But what we've seen over the last, I would say, 1 or 2 years or 3 years is a lot of Sitecore customers who are using Azure on PaaS environment, they start with Azure and it works great, right? Until you ask for more, right? So if you have use cases where you're looking at a multilingual search, you have a use case where you need to index content heavily, you have a use case where you need to send a lot of emails. What we're hearing in the marketplace and what we're seeing our customers doing is, a lot of people are struggling with Azure Search. They're having performance problems, they're having scalability problems, they're having feature gap problems, and so on and so forth. And that's kind of what we're seeing is, Azure Search limitations as it relates to Sitecore that we've seen is around high frequency or heavy content indexing needs, large number of fields. I believe the limitation is about 200 fields or so, if I'm not wrong, somewhere around that. And then, if you have multiple languages, specific languages that they don't support today. Obviously, Azure Search is a proprietary kind of search engine. So if you're looking at working with a client that wants to extend search to the next level, they want to do a little bit more, add some kind of a capabilities around, type aheads or things like that, there's a functionality gap around Azure Search. I'm sure they'll catch up, but today, what people are expecting out of search, Azure Search doesn't provide. And then, as you scale up, right, and in large to kind of extra large deployments, Azure Search costing is actually pretty steep. It starts small, but then it's pretty costly as you kind of scale from an infrastructure perspective. So, that's another angle. And then if you have compliance needs, if your enterprise kind of compliance needs where you have to have multiple disaster recovery regions and things like that, Azure Search today is only available in certain regions. It's not available in all Azure regions. So that's another limitation where companies who are trying to take Sitecore and meeting that compliance needs, they just can't do that with Azure Search. So, that's kind of what our experience has been in kind of working with Sitecore customers. Most of the customers that have come to us initially were using Azure Search, and they're like, it's kind of coming to its knees, and we want an alternative solution. So, now that you have a problem, how do you solve that problem? And a lot of customers, what they do is, they actually solve that problem with Solr, right? And for those of you who don't know what Solr is an open source enterprise search platform. It's free of charge. You can go to their website. It's an Apache project, started in about 2006, if I'm not wrong. It's forked out of Lucene, which is the core kind of search libraries that has been there since 2001, and it has been forked out of that. The main reason for creating Solr was that Lucene was not scalable, and they wanted a way to scale Lucene on multiple nodes, because at that time there used to be heavy machines, and you could just put Lucene, and there wasn't enough data. But then as data needs grew, Lucene was not kind of doing the job, and they created Solr, and I think the short form of, or the abbreviation is Solr. I think it's called Search on Lucene with Replication, I believe is what it's called, and that's kind of how it started. Solr is not a untested technology. It's used and trusted by 90+% of Fortune 500 companies. It has a very, very strong community. It is one of the true open source search engines out there. Obviously, most of you might have heard about Solr and Elastic. Elastic is open source, but in some sense, it is driven by the Elastic kind of company and not true kind of open source from a community perspective. Solr has always enjoyed that, and part of its kind of success is really kind of driven by, very, very driven by community, and it's true open source. Massively scalable, used by Salesforce today, Walmart, Iron Mountain. I think last time I was talking to someone on the sales team in Salesforce, he was like, we run about 900 servers of Solr, right, in their environment. So, that's the kind of scale it can reach to. So if anyone says that Solr is not scalable, you should point that kind of, notation to them. Walmart itself has tons of servers. And Iron Mountain, I think last time we were talking to them, they have about, I think, 200 or 250 servers in kind of different data centers that are running across the globe for their, for their needs. Solr is pretty feature-rich. So from a feature functionality perspective, you name it in the search, field today, whether it's faceted search, fuzzy search, spell checking, geospatial, multi-language, most of the features that people are used to from a search engine perspective, even whether they use it or not, is there. Obviously, it needs customization. Autocomplete, search suggest. We guys are, in a Google generation. We're so used to having good search that we sometimes forget what it takes to actually get that working. Content extraction from file types, PDFs, PPTs, things like that. Highly customizable to specific needs. I think that's one of the things that attracts a lot of people to Solr is because it works great out of the box, but it has the ability to customize to people's needs. And that's why a lot of intranet-based companies use Solr, right? Because they have their own use cases, they have their own needs, and those business logic and kind of, certain requirements can be implemented in Solr, where sometimes in out-of-the-box kind of an as-a-service environment, those things are not feasible, or you can't kind of configure and optimize for certain use cases that they have. Search engine relevance is a vast topic. I'm not going to go into detail, but it has customizable relevance models. So we work with some companies that spend millions of dollars in trying to make sure the 10 results that come are the perfect results. That because their business depends upon what they show to the users. So Solr, the good part is it has ability to customize those relevance models inside its search engine, whether that's using machine learning or whether that's using traditional TF-IDF approaches and things like that. So that's kind of part of the packages. And then more recently in the last 2 years, there's a lot of machine learning development happening in there, BM25 models and things like that are available in Solr. So in short, it's a pretty extensible and comprehensive open source package, which is probably the reason of why a lot of enterprise search companies have a hard time because Solr actually has is pretty mature from a feature functionality perspective. So that being said, right? So the good, I think as you can see, there's a good, bad, and ugly, and for those who haven't known the notation, there's a movie, Good, Bad, and Ugly, and I kind of created the three slides based on that. So the good part about Solr in Sitecore world is Sitecore integrates natively with Solr, right? So they have a Solr integration out of the box. You can use Sitecore. You can use Solr as part of your Sitecore deployments. So that's great. I think the bad part for folks who go with Solr is an open source software that needs to be set up. It needs to be configured. It needs to be deployed. It needs to be scaled. It needs to be optimized, right? So a lot of the Sitecore developers who enjoy the positive aspects of Azure Search, where all they have to do is plug in, Azure Search and it just works, and they don't have to do anything. They don't have to do setup. They don't have to worry about kind of scaling and all that kind of stuff. The promise, at least, is there. Whereas in Solr, you have to kind of do that all by yourself because there isn't a turn-on service that can do that for you, and Azure doesn't offer Solr as a service or anything like that. And the ugly part is that you have to do it yourself. So, that's, I think, the worst part. And I talk to a lot of Sitecore developers, and the part they hate is they're like, hey, I want to spend my time working on Sitecore feature functionalities and not kind of spend my time setting up, these deployments. And it applies to self-managed and kind of PaaS Sitecore offerings. Sitecore managed cloud offerings, I think, starting this year, what you'll see is they're actually offering Solr as a service as part of their managed cloud offering, and then that is actually powered by SearchStax behind the scenes. So our company powers Sitecore's managed cloud offerings today. So that's, but if you're running self-managed and PaaS offerings, you don't have a choice as opposed to either do it yourself or find a vendor that can actually take that pain away from you. So so that's kind of the brief context, right, around Azure, Solr, what it is, some of the challenges, and kind of the where things are. Now, kind of diving a little bit more into the Solr aspect of things. So now you're going into Solr world, right? Now you have the problem at hand of now setting it up for your client or setting it up for your own company, right? If you're deploying Sitecore on premise or in the cloud. And maybe a lot of people know kind of these terminologies, but as I'm talking to a lot of people, we have a booth outside, and I was interacting with a lot of folks, and I was kind of surprised that there is still a lot of fuzziness around what is Solr Cloud, what is master slave. I think there's still a confusion around what is master slave versus what is Solr Cloud, and is Solr Cloud actually only available in the cloud, right? In the sense in the public cloud environments, or is it available on premise? So there's a lot of confusion there. So what I wanted to do was just maybe spend a few minutes talking about these different topologies and kind of help you kind of clarify or at least give you a little bit more information around that. So I think to understand that, I think what's helpful is a little bit of a history, right, of solar. So like I said, right, I mean, when solar started, in 2006, most of the time, the data kind of fit into a single machine, right? So what you didn't have to worry about was, all you did was you started a standalone Solr server, and you said, I'm going to index a bunch of data, and now I can query a bunch of data, and that's all I needed. Great. So, and that's what in traditional sense used to be called a standalone Solr server, right? And that's pretty much you need to do. You need to download Solr, you need to start it up, and you need to set it up. Now, what happened somewhere around 2000 Solr version 3.6 to 4.0 was, people started to generate a lot more data. There used to be a lot more data that people used to push in Solr, and a lot of companies, what they saw, especially consumer companies, was that there was a lot more traffic that was coming to their search engine, which typically, they couldn't really support in a single machine. They needed replication so that they had two or more servers that could handle the load, or for redundancy purposes, they had another server. In some cases, the data, the enterprise companies, the data was large, right? Their query volume might not be that high, but their data requirements were very large, so they had to split the data into multiple machines because one machine couldn't hold all the data, or if it could hold all the data, it wouldn't serve the queries in a matter of tens of milliseconds, right? So that's a challenge. So what people used to do, in Solr 3 or Solr 4, even I've even seen customers doing that today, is Solr came up with the concept of master slave, right? So what that meant was you configure one Solr server, and then you configure another Solr server, and then there used to be a replication handler, so to speak, that used to connect from your master to slave, and you only dealt with your master server, and then Solr was responsible behind the scenes to push that data periodically to your slave environment, and the slaves were primarily used for reads, right, not writes. So all the writes used to go to master, and all the reads used to go to slave. And there still used to be a question about, if your master is down, your indexing is down, right? So you had near real-time indexing or anything, your system was down for that period of time. So, but that has been, very common in a lot of environments, and that used to be what master-slave used to be. It used to be a pain to manage. I've managed it myself in a lot of companies. I think in 2008, I ran search team at YP, and that's what we used to do. We used to have 6 shards and 3 replicas and 20, 30 servers that we were running Solr for our websites, and used to be a pain to manage. And then to alleviate that pain, what Solr came, and it has nothing to do with cloud for now, right? So this was whether you're on premise or whatever data centers you are, this is kind of what you used to do. And then in Solr 4.0, to solve that problem, Solr came with a feature that was called Solr Cloud. So they named it, and it's kind of hard because it had nothing to do with cloud, but it was named Solr Cloud. And the whole idea about that feature set was that it made kind of the data partitioning, data distribution, data querying, load balancing much more easier for customers or for developers, and they didn't have to do the master-slave configuration. And the Solr Cloud environment, it was just a feature, right? You can enable that feature in a single node, or you can enable that feature on hundreds of nodes, right? So it doesn't really distinguish between whether you're running a multi-node environment or a single node environment, but the feature used to be called Solr Cloud. So there's a little bit of a history there, and a little bit, from my personal opinion, wrong naming convention from a community perspective on Solr Cloud. Now, so that's kind of, so that's why when you say standalone or Solr Cloud, it is still a single machine that can be run in a standalone mode, or it can be run in a cloud mode. And then, master slave we've touched upon. And then the question becomes, now how do you make Solr Cloud highly available, right? How do you make sure that it's running across different machines? If the machines are not resilient, if the problems are happening, how can it recover itself? How does it make sure that there is resiliency baked in and all that kind of stuff? So that's, to me, is what I call kind of high availability Solr Cloud topology, right? And we'll go into a little bit more detail around that. And then finally, and more recently in Solr 6.x versions, I think it was 6.6 or so, is when they realized Solr Cloud is working great from a single data center perspective. But then if you have a disaster recovery requirement, if you have a cross-region requirement, managing those environments in 2 data center is a lot of pain. And in recent versions of Solr, they have a feature called CDCR, which is cross-data center replication, that allows Solr to actually sync data from one data center to another data center and do that through the configuration, and then it can be deployed and managed a little bit more easily. Prior to that, what people used to do, and again, we've worked with some companies that used to do is, they used to actually have queues in front of Solr and then manage the data distribution across 2 different data centers themselves. Unlike Oracle or any other software, there's no auto-replication or auto-sync between the 2 data centers. So all that kind of stuff has to be managed, by developers themselves. So that's kind of the 4th kind of topology in kind of the Solr world. Does it make sense? Yeah? All right. So, kind of going down, so what I want to do is, kind of just talk about, okay, what does a Solr Cloud or a standalone server look like, right? In a typical Sitecore deployment, you have a Sitecore app, and, in a lot of scenarios, if you're integrating with Solr, all you need to do is spin up a, VM in Azure, in AWS, or on your laptop, and, just set up a Solr server on top of it, and then you connect your Sitecore app directly to Solr, and that's it, right? And in a lot of development scenarios and stuff, that topology works. If you're trying to run Solr Cloud, you need to have Zookeeper that's built in and embedded inside Solr. If you just turn on a cloud mode, it's just a simple configuration while starting. And then you're running a single node server, so right, you can completely run your app with a simple service that's running either on a simple machine or any VM out there. And Solr and Zookeeper can run on the same server. Ideally, this kind of topology and architecture is ideal for like development or QA environments. You don't want to run production in this topology, as obvious reasons. There is no high availability baked in. There's no redundancy, nothing like that. So best practices wise, never run single node in a production environment, or obviously there are obvious problems there. And again, I said, no high availability, no fault tolerance, and that's kind of it, right? So now I think to move on from there is, that's great. Now you have a Solr, Sitecore. Sitecore has very well documentations. I mean, our site also has documentation on how to connect Sitecore with Solr. 3 easy steps, plug in your URLs, change your configurations, done. Now the question becomes, it's great for development, great for QA. How do we take it to the production, right? How do we make sure that we take this architecture from a standalone server and make it highly available? And let's kind of see how we do that, right? So it's a journey to high availability, right? I mean, I have a couple of slides that kind of go through this journey, and the reason I've done it is I've started with like a little bit more added a complexity and kind of identified what the problems might be there, and then kind of taken it to the next step. So in this case, hey, high availability means if my server goes down, I don't have another one that's serving that, that application. Simple. All I need to do is start another Solr server and have my, Sitecore app directly talk to Solr in a Solr Cloud mode. You can tell Solr that this is another, node in my cluster, and you don't need to worry about, Zookeeper ensemble or anything. And this is a simplest architecture that gives you kind of Solr high availability, right? So in some case, you're doing a maintenance on a Solr server, or in a cloud environment, there is a node replacement or anything like that. You don't need to worry about downtime. Why? Because if you take one server down, your still Solr server is serving the needs, and your Sitecore app is working completely fine. Now, the challenge with this kind of an architecture is that your Zookeeper is still a single point of failure, because Zookeeper is not highly available. So in case your first machine goes down, right, nothing happens to your Solr server, but let's say something happens to your Zookeeper service or Solr or the machine itself, Solr Cloud is going to stop functioning because it needs a Zookeeper to function. And if the Zookeeper is not available, your host. And at that point, you can't write into your Solr server. So that's a problem there. So how do we solve that problem, right? So, I mean, Zookeeper best practices. Zookeeper requires, at least 3 nodes or at least 3 servers to create what they call a Zookeeper ensemble. Ensemble is nothing but a cluster. Ensemble is nothing but a cluster. It needs 3 nodes at least. It can have more, but at least it needs 3 nodes to provide the kind of resiliency and and peer syncing that you require. So your architecture has become a little bit more complicated now. So you have a Sitecore app, you have now 2 Solr servers, and then you have 3 nodes that are running your Zookeeper ensemble to provide kind of high availability, right? Now, this is great. So now you've solved the problem of Zookeeper high availability, but what are the challenges in this kind of an architecture, right? So the challenges here are that in cloud environments, if you're running in a cloud environment, we all know that when we recycle servers, when there is a node maintenance or anything like that, the IPs get recycled. You can't rely, in a traditional data center world, you can rely on your IPs that they're not gonna change, but in a cloud environment, that reliance has gone away because you have to build in a way that your entire architecture is resilient, right? So in that scenario, if the node goes down or the node gets recycled, it's a big problem because you have to now go into your Sitecore app, change the configurations, or if you're using a DNS server, you have to go and change your DNS settings. If you're using A routes or anything like that, that needs to be changed. And then you have to go into your Zookeeper ensembles and change all the IPs and all that kind of stuff that are pointing to Solr, right? So it becomes a time-consuming exercise to make sure when that happens, someone has to go and do the manual work, and there's no push button that kind of does that. The other problem, which a lot of times people don't realize, is Solr advertises that the Solr Cloud kind of does load balancing and all that kind of stuff. But if in your application, you can't specify 2 URLs or 2 Solr IP addresses, right? Unlike Zookeeper Ensemble, where you can actually specify all 3 nodes when you're communicating with Zookeeper, in Solr, like when you're integrating with your application, you have to provide it either 1 IP address or 1 URL. So now the challenge becomes if you're providing that 1 IP address, even though the load might be balanced between the 2 servers, if something happens to that IP, your application is out, right? So in some sense, yes, you created 2 servers, but you're still dependent upon that one machine whose IP or the naming convention is stuck into the Sitecore app. So how do you solve that problem, right? So you solve that problem with actually putting an application gateway or a load balancer in front of your Solr, right? And as soon as you put kind of an application gateway, you've created an architecture that allows you to create a fully high availability Solr infrastructure. You have the ability to scale up, you have the ability to scale down. As your load increases, you need to scale, you need to scale up, or as your data increases, you can partition your data, create shards, create replicas, and so on and so forth. So in this case, you have now a high availability Zookeeper ensemble, you have high availability Solr servers with replication, you have a load balancer and an app gateway, and you have the ability to scale up without re-architecting, the entire infrastructure, right? So that's kind of your, so to speak, reference architecture in some sense from a Solr high availability. Now, as you can see, right, I mean, if you're taking Solr to production, if you're a Sitecore developer, you used to just plug in a Azure search URL. I didn't need to do anything about it because Azure used to take care of that. But if I'm going a Solr route, Sitecore isn't providing any help for that. You have to now do and kind of go and implement that for each and all of your customers. Obviously, you can always go with a simple approach, but then you're creating a liability and a risk for both yourself and the customer, right? And kind of putting the website in jeopardy. So that's kind of the architecture here. So that's kind of the journey, right? From going from one server to kind of a full architecture. That's what it takes. Now this is great, right? You've created a high availability system, but then anytime you're managing a system or anytime you're putting an application together, the second question is, how are you making sure that backups are taken? How are you making sure that if data corruption happens, data loss happens, how are you backing up? How are you able to recover that, right? Solr deployments. So now what do you do, right? There is no push button in Solr that allows you to do that. And if you start doing, a lot of people say, oh, what we do is, we just do disk backups or we do, AWS snapshots or, things like that. And that's, solve the problem for my backups. The problem is in Solr, that doesn't work. Why? Because Solr, internally uses a file system to always write onto the disk. And it always has sometimes pointers and stuff open that are writing to the disk. So what that means is, at a time when you're taking a snapshot, at the same time, Solr might be writing to the disk, so you have a very high chance of corrupting your index. So what that means is the backup that you've taken, you can't really rely on because that might as well be corrupt. So what do you do, right? So And again, in a Solr Cloud environment, this is a snapshot taken from Solr's website, right? High level, if you've just skimmed the Solr's website, they say, we provide backup and restore APIs, so easy to use. But in small, and I've highlighted this part, is like Solr Cloud backup restores require a shared file system mounted across all your nodes, right? And that's not an easy exercise for a regular developer, right? Now you have to go into ops, now you have to figure out how you're gonna create a shared file system. I mean, how many of you have actually created a shared file system and mounted on your servers, right? Probably less than 10% people here, right? So, I mean, I don't wanna do that. So now the question is, this is what it looks like if you wanna take Solr to the next level and make sure you have backups on Solr, is you have to create a shared file system. That shared file system has to be mounted on all your Solr nodes. You have to do that part manually. And once they're mounted on all the servers, then you can actually use the Solr Cloud backup and restore APIs to make sure the data is backed up and things like that, right? Even after you do that, the challenge still on your shoulders is how are you going to create backup schedules? You have to do it, right, yourself. There's no support provided for that. You have to do retention logic and cleanup. Typically, there's complex retentions logic around, I want to keep it for 30 days, I want to keep it for 7 days, I want to create one backup that is available for 2 months or what have you, right? Whatever the client's kind of enterprise backup and restore kind of requirements are. You have to build according to that. And then any kind of compliance compliance needs you have requires you to make sure your backups are tested, your backups are verified, your backups are making sure that you actually have tried that verification and restore. And if you're not doing that, that kind of doesn't meet the compliance needs. So you have to build those backups and restore procedures yourself. So, but this is kind of what it takes to kind of put a backup and recovery solution on top of a Solr Cloud, as opposed to saying, I'm just going to start doing disk backups. So, so now you have a proper system that is backed up appropriately. You have, you have the ability to restore. You've architected in a high availability manner. But again, in cloud environment, what if the data center goes down, right? In a lot of Sitecore deployments, again, I'm not a Sitecore expert, but what I'm hearing from the field is a lot of customers are coming to us and saying, we're running Sitecore in a multi-geographical region, right? So we have an America region, we have an APAC, Australia region, we have a Europe region. How do we make sure now Solr kind of maps to that same requirement? I believe Sitecore might be having capabilities to make that simpler from a Sitecore perspective, but from a Solr perspective, again, it's the ugly part, right? You got to do it yourself. So now, what does an architecture of a cross-region Solr deployment looks like, right? So to create a highly resilient, fault-tolerant, if my data center goes down, and Azure is, Azure doesn't have a very good history of making sure the data centers don't go down, unlike AWS. So we've seen this US Central, we've seen some other data centers kind of go down every now and then, and you got to make sure that the disaster recovery strategy is put in place to kind of make sure these environments can be spin up and and turned down on demand, and then can be replicated across different regions. So, from if you remember the last diagram, there used to be a Sitecore app that used to connect directly to the load balancer, and then there used to be a VM, and then the load is balanced and things like that. But when you're suddenly going into a cross-region replication or a DR or a failover, now you have to introduce another component on top of your stack, which is either a DNS failover or traffic managers, or there's different ways to do that. But essentially, in this case, what I've done is basically now you have to configure a DNS that talks to your primary or active Solr deployment in a particular region, and then you have a DNS failover setup that could fail over to your secondary region or to your tertiary region, depending upon how many regions you have. And that's another added complexity, and that this DNS will be now used by Sitecore as opposed to the load balancer URLs directly, right? And then on the back side of things, how do you make sure that this Solr cluster is synchronized with this Solr cluster? Sitecore doesn't have any capability that can sync to both the data centers at the same time. So it is the responsibility of the implementation partner or the guy who's implementing it to actually set that up. So in that case, most of the time what you do is you pick up your primary Solr environment, that's where all the data is getting synced. That's where everything is happening. And behind the scenes, there is a data synchronization happening between your primary data center and your secondary data center, where all the data is replicated across different regions, whether that's one region or kind of multiple regions, right? And you have to do that, and then each of these are still kind of backed up in the same region that they're running to kind of preserve data sovereignty and GDPR requirements and things like that, right? So that's kind of the architecture that looks like if you are running a Solr environment in kind of a disaster recovery mode with a hot DR kind of a capability, right? So your traffic routing is possible. You now can be scaled to multiple regions. Regardless of data centers or servers, your system is pretty reliant. I think the main thing is the DNS, which I think we can live with DNS not being highly available, because most of these cloud providers are providing DNS with certain SLAs and things like that, so we don't have to worry about that aspect. But that's kind of your Solr Cloud with CDCR. And it's probably a lot to take, so I'm going to pause for some time. All right, now, enough of kind of the complexity. There is an easier way, right? And this is kind of where, my shameless plug kind of comes in, is, we've built a company completely that runs around it, right? The core purpose of the company is to really make it easy for people to run, deploy Solr, manage Solr in the cloud, wherever they are, across the different clouds, across different regions. So what I want to do in the next, kind of 10 minutes is essentially give you guys a demo of how easy it is to kind of, start up a kind of production-ready, even, whether it's cross-region replication or anything, using SearchStax, and kind of walk through that process. I'll probably do a little bit too big. Is it visible? Probably not to the people in the back, but hopefully I'll talk through it. So SearchStax is a SaaS offering. So this is a dashboard. A lot of customers use it for managing their Solr deployments. What it is showing is essentially, I have right now 4 kind of deployments running. Some of them are running on AWS. Some of them are running on Azure. Some of them are running on North Virginia data center. One of them is running in California data center. And there are a mixture of cluster topologies. There is a 3-node cluster. There is a 2-node cluster, and so on and so forth. So before coming to the presentation, I kind of spin these up. But essentially what we've made is like you looked at kind of the production grade clusters that we have. Now what SearchStax does is, this is what we do, right? So if you have to create a deployment that is a production grade deployment, all you have to do is, give it a name. I'll call it SUGCON presentation. I'm going to say I'm going to run on Amazon Web Services, Azure, Google Cloud. Really depends upon your choice where you want to run, and then you select the region where you want to run this entire Solr deployment on. And let's say, we support all regions across the 3 cloud providers except China, just because from an entity perspective we need to have a separate entity in China and all that kind of stuff. So that we don't offer China today, but apart from that, we offer all the regions across different cloud providers. So you say, hey, you know what? I want to run in Ireland. I want to run in European region, and we've created some plans, and I won't go into more details, but we've created some plans for non-production environments, which are single node deployments that you saw in the topology. We're experimenting with I'm in a staff mode, but we're experimenting with next generation clusters. And then there is typically a dedicated clusters, which are, these clusters that can be run in any of these cloud providers that you can say, I want to run based on, my Sitecore deployment needs a 16 gig or 32 gig or what have you. It's kind of basis on that. These clusters by default come with 3 nodes. You can say, I want to run 6 nodes instead of 3 nodes. And in this case, I'll say, let's just run 3 nodes. And you select the Solr version, right? I mean, that's one of the things when you're working with your clients. If they're on Sitecore 8.x, it's a different Solr version that is required to run that there. If they're running on Sitecore 9, there's a 7.2.1 requirement these days. So we support starting from, we actually have Sitecore customers that are on 5.1 as well. And ranging from 5.1 to up to latest, we support all Solr versions. We have a stringent version policy that when a particular version comes out, within 4 weeks, we try to kind of get that version certified on SearchStax and make it available. So let's say, I want to run a Solr 7.2. You want to do encrypted data volumes. Again, you've heard from clients, how is my data protected? How are they encrypted? All that kind of stuff. You don't need to do anything. We can say, I want to encrypt my volume when I'm starting Solr deployments. And then once you do that, and that's pretty much it. What it does is behind the scenes, our automation software goes and does all the things that we saw, and it actually spins up all the Zookeeper nodes, spins up the Solr nodes, configures Java, configures SSL certificates, configures everything that's needed under Sun to proper partitioning, disk partitionings and things like that, and it spins up a deployment that will be ready to run. And maybe while we come back in 10 minutes, we'll see that this particular deployment will be up and running. In AWS, it typically takes about 15 or so minutes. In Azure, it takes 60 minutes, mostly because Azure app gateway is notoriously slow, and it takes about 60 minutes to start. So, and GCP also takes about 15 to 20 minutes to start an entire cluster. And so, once you're there, so what you see is this is my test cluster. Let me go to the SUGCON cluster that I created. There it is. So here's a proper running Solr environment, completely production ready. You guys have full access to your Solr environment as you're used to. There's no proprietary APIs or anything like that. You have access to your Solr admin interface. You have access to Zookeeper. You can upload configs, make any changes, do any of these things. And as you can see, this is running 3 dedicated Zookeeper servers, 2 dedicated Solrs. You have full kind of options here. For the backups and restores, we actually provide the ability to completely create one-time backups. So again, going back to the case, what I'm going to do here is for this particular deployment, I'm going to say I want to create a one-time backup, and I also want the backup to be cross-region replicated, right? So that if you're implementing a cold DR strategy for your customers, you don't need the servers running in the different data centers. You can actually have just the backup that is available in the other data center. In case that data center goes down, you can just spin up a new deployment from the backup, and that entire ability is provided through the dashboard, right? So I'll say, I want to make sure that this backup is actually backed up in Asia Pacific Singapore region. And what you'll see is after about 2 or 3 minutes, this entire backup will be available here. And then once your backups are available, let's say a disaster happens, something happens to a data center, or even for your client needs, maybe they're moving from one data center to another, you can pick up any of the backups that you have, and you can say, I want to actually restore this backup onto an existing deployment that I might have. And you can say, I want to restore this particular backup on a deployment, and then click restore. And all it'll do is basically take that backup and restore that onto a deployment, right? So that entire process of configuring this in a different environment, doing all that kind of stuff, is pretty much reduced to like point and click 3 or 4 clicks that you have to do. And that entire thing does the kind of title of the presentation is like you can have a world-class Solr deployment in 30 minutes or even less, right? So that's kind of what we do as a company, and just makes kind of hopefully it makes Sitecore developers' lives easier and really easy to kind of manage and scale Solr. I think that's what I had from a demo perspective. I think what I'd like to do is kind of turn the tables around a little bit, questions that I can answer. Yeah, go ahead.
Yeah, hi. My name is Shishir. I'm representing Content Bloom. I like what you
your name?
have
Sorry,
there.
I didn't get your name.
Shishir.
Shishir?
Shishir Banerjee.
Shishir, okay.
Yeah. So I have a question because I have been, meeting enterprise clients, and a lot of them have these issues which you are solving here. The only problem which I see is if we go together and I pitch you to them, or maybe, we do this, who are selling, Microsoft, Google, and those people, they have such a, ecosystem over there. How you position your brand against those guys?
Well, I don't think we're competing against those, right? I mean, none of these cloud providers, until something has happened in the last 30 minutes, they don't offer this capability, right? There is no Solr as a service. And I know the Amazon folks really well because when I started the company, we had very good talks with the A9 folks because they were trying to launch cloud search at that time. And we were collaborating together with them. And they were trying to launch kind of cloud search and Solr as a service, but they've been unsuccessful, or maybe the market isn't big enough for them, right? So who knows? But they haven't come out with that. So from our perspective, I mean, we're partnered with all the 3 cloud providers. We are advanced partners with AWS. We recently, last year, launched a partnership with Google. So we kind of support all the cloud providers. They don't care because we're not competing against any one of those services. Now, yes, the competition might be they want you to use their cloud search service, right? Yes, I mean, I think that to me is a conversation at a different level, right? Because the question is, we want to talk to customers who've decided that Solr is the way they want to go, right? And if that's kind of, if they've formed their mind around the fact that I want to stick with open source, I want that customizability, I want that flexibility, I want to be in that platform, then that's where we come in, and it's totally okay if they want to go with cloud search and if that meets their needs, right? Totally fine. And that's the same with Azure search, right? Hey, Azure search works for you? Great. Good for you. And that's how we kind of deal with that question.
Yeah, because when we are actually technically consulting, right? So Solr has to be positioned because not all the clients know about these things.
Yep.
So I have met a lot of startups who, use multiple instances and working with them and, messing up things. And then their websites go down and they come back to us that do some QA and everything. So if this kind of product has to be positioned, so that was my question, means how do you position it with?
Well, the way we position it is simple, right? I think, you can do everything, right? I mean, how many of you actually build a search engine here, right? Probably pretty less, right? I mean, there's Azure search. I think all of us would love to use a service that has a URL, but how many of us are actually dedicating our time to say, I'm actually going to create an Azure search environment, or I'm going to create an Azure search service? Not a lot of people, right? I don't see in the industry a lot of people saying, I'm actually creating a competing search engine where there is already Solr, right? And that's the same question, is like, would your company want to spend time and resources building a search engine themselves? Probably not, right? I mean, there's a technology out there that's mature enough. Go use it, right? I mean, I don't generate my own electricity. I just buy from an electric company, and it just isn't worth for me to generate my own electricity.
Thanks.
Sure. Yeah, go ahead. Yep.
And if I want to update some fields in the schema file,
Sure.
How do I do those
So,
things?
from SearchStax perspective, we offer you Zookeeper Ensemble, right? So you will have access to Zookeepers. We have now REST APIs that you can use our APIs to upload. So, in all practical sense, what you have to do is open up Solr schema file, right? Or Solr config file, add your own add your own handler. If you've written a customized handler, you can add the XML changes there, and you upload it to SearchStax or Zookeeper. Like we're not taking away what you're used to doing it with Solr, right? We're just making it easy to manage that entire process. So you can use our software to directly upload those files, and those will be automatically, replicated. I mean, Solr has a capability called Solr collection reload ability. Once you upload those configs, those can be replicated across all the nodes automatically, and that's typically how our customers use. Our customers use a lot of plugins. They have created some plugins to create advanced search and things like that. You can deploy those directly onto your Solr environment. You don't have to SSH to them. We have a UI where you can do that. And that's, that kind of a flexibility and customizability we provide.
Okay. One more thing. What would be the endpoint for the Sitecore, like in Solr SearchStax?
Yep.
Which one will be the endpoint? How do
This
I
would be
connect with the Sitecore?
No, that didn't work well. So this would be the endpoint that you would point into your Sitecore deployment. And if you go to our docs, what you'll see is we have a integrate Solr with Sitecore 9. I mean, it kind of gives you, again, we're not Sitecore experts, so if you find out problems in the documentation, please let us know. Yep. We used a Sitecore consultant to actually help us build this documentation. So, what you have to do is really, make these configurations, use your Solr service, and then, all you have to do is here, point in, maybe, where is the Solr URL name? Yeah, so Solr URL, right? That's the parameter that goes in. And that's kind of the configuration that you have to do on the Sitecore side. And once you've done that, your typical populate schema, your populate schema and everything just works out of the box from Sitecore.
Okay, thank you.
Yeah, go ahead. Sorry? Leader election,
Yeah,
sure.
so how does that happen? Does it happen based on the load of?
That could be a full 30-minute talk, but
okay.
Leader election is kind of Zookeeper's own kind of capability, right? I mean, leader election actually happens both on the Solr side as well as on the Zookeeper side. There's two completely separate processes that manage that, and both softwares manage it themselves, right? So, again, I think, maybe we can take it offline because it's a complex process that goes behind the scenes. There is a full timeout mechanisms, and then one of them starts to elect, and then the other one tries to also do the same thing, and then they fight with each other, and then one of them wins, and there's a complexity around that. But happy to chat with you about that. All right, I think the time's up. Sorry, guys. Any other questions? I mean, again, if you have further questions, we're sponsoring the conference as well, so we're outside. Feel free to come stop by at the booth, and happy to have all the discussions. Thanks, guys. Thank you.